This is 6.5 notes, analyzing and sketching graphs. And throughout this section, we are going to draw graphs from a given situation, and we are going to interpret graphs and turn it into interpreting what's going on in the picture. Okay, so the main thing is we're going to have two labels on our graph. So when you sketch a graph, you still need to label. In this case, it's time and distance. When the slope is positive, when the slope is increased, or when the slope is going up, the value is increasing. When it's a horizontal slope, when it's a zero slope, there is no change, right? And here, when it's decreasing, or when it's going down, when it's a negative slope, it's decreasing, right? So if this is distance and time, this would be I'm walking faster, this would be I'm not walking at all, and this would be I'm walking back to where I started from. So example 1, we need to analyze these two graphs in Belfast, Maine and Newport, Oregon. And it shows the temperature throughout the day in two cities. So let's start with Belfast. I'm going to split question A into two parts. Okay, so this is Belfast. So the temperature starts pretty low, so it increases throughout the day. And then the temperature begins to decrease at a faster rate the rest of the day, okay? So we're increasing and then we're decreasing. So I would say the temperature, I'm going to write my up arrow for increases so you're not watching me just write out a bunch of words. The temperature increases at the beginning of the day and then decreases at a faster rate the rest of the day. Okay, and in Newport, the temperature starts off pretty warm, and then it decreases at a constant rate. We know it's constant because it's a straight line, okay? And then the temperature stays the same for a while, and then it increases at a constant rate for the rest of the day. So I would say the temperature decreases at a constant rate. I couldn't say that on the first one because these aren't straight lines. At the beginning of the day. And then stays the same. And finally, increases at a constant rate. Okay, I know those are long answers, but that is how you interpret a graph. So I need to make 3 comparisons, and when we compare something, we take 2 graphs and say what we see is different and what we think is the same. I'm going to do up here since I'm out of room. So I would say both graphs show increasing and decreasing temperature. Okay, that could be one. A second one is both graphs are nonlinear. Okay, you can agree that neither of them have just a straight line. But Newport is made up of 3 linear sections. Okay, and what I mean by that is this is one linear section, this is the second linear section, and here is the third. Okay, so these are all 3 linear sections, but together it is a non-linear line. I would say Belfast is warmer at the end of the day. Belfast is warmer at the end of the day than the beginning. Okay, there are multiple other things you could write down. Those are just a couple. Moving on, you have 2 on your own graphs. I want you to do these on your own, and we're going to check them in class tomorrow. So this is the vertical distance, this is a horizontal distance, and this is a pelican. And then we have an osprey. It's just a different type of bird. This is the horizontal and the vertical distance. So this is how high they're flying. This would obviously be the ground. And I want you to describe the path in each bird and then make 3 comparisons. I'm not going to write these out. We will check them in class tomorrow. The other way is I'm going to give you a situation and we have to sketch the graph. Okay, and I talked about this a little bit at the beginning. You need to make sure that your sketch graph has labels. So I'm going to label my vertical axis speed, and I'm going to label my horizontal axis time. Okay, one thing you will notice about these graphs is they have no numbers. Okay, when you sketch a graph like this, when you're sketching a situation that isn't specific with its units, you do not need to have units on your graph. Okay. So here's how we do this one. You need to break up your word phrases into sections. Okay, so my first word phrase is a stopped subway train gains speed at a constant rate until it reaches its maximum speed. Okay, so that would be my first thing. So I'm starting a stopped subway train. I'm obviously haven't gone very fast. So a stopped subway train speeds up until it gets to its maximum speed. Okay, the second part of this, it travels at this speed for a while. Okay, so if I'm traveling at that speed for a while, I'm not increasing speed, nor am I decreasing speed, so it stays the same. Okay, and then the last part of this is, then it slows down at a constant rate, so I know it's going to be a straight line, until coming to a stop at the next station. Okay, so here I am, I'm stopped, I'm speeding up, staying the same speed for a while, and I'm coming back down to the next subway station. So that would be the graph of example 2. Part B, this is television size. So as television size increases, the price increases at an increasing rate. Okay, this increasing rate, notice it's not constant rate. Okay, so this is not going to be a straight line. Good grief. This is going to be a curved line. Okay, we knew the last one was straight because it said constant rate, so this would be straight line. Okay, and once again, I have to sketch my graph. So I have the vertical axis is going to be price, and my horizontal axis is going to be TV size. Okay, so it says as television size increases, so as this gets bigger, the price goes up at an increasing rate. So if I have a small TV, the price is going to be low. If I have a big TV, the price is going to be high. And I know this is an increasing rate, so it's going to be a curved graph. Doesn't have to be perfect, okay? But it would be something like that. So if the TV size is really small, the price is going to be small. Medium-sized TV, medium-sized price. Large-sized TV is going to be a larger price. All right, number 2, on your own, it says a fully charged battery loses its charge at a constant rate until it has no charge left. You plug it in and then fully recharge it. Then it loses charge at a constant rate until it has no charge left. So I see constant rate and constant rate, so I'm now going to use straight lines. Okay, I need to set up my graph. I need to label my axis. Time is usually going to be on the bottom. Okay, not for all of them, but for most. And I'm going to put cell phone charge on my vertical axis. Okay, so a fully charged battery, which means it's charged all the way, so I'm starting up here, loses its charge at a constant rate until it's dead. Okay, this is dead and this is full charge. Okay, then I plug it back in and it gets full charge. Okay, so I did, let me do these in color so it's easier for you to see. So that would be a fully charged battery loses its charge until it has no charge left. This blue section is you plug it in and fully recharge it. And this green section is going to be it loses its charge at a constant rate until it has no charge left. Okay, so that is the graph of on your own number 2. Number 3, I want you to pause this. I want you to try it on your own. The key word I'm going to point out to you is that it doesn't tell you that it increases or decreases at a constant rate. Okay, so this is a decreasing rate. which means this is going to be a curved line. Okay, so pause this, try it on your own, press play when you're ready, and if you need to do some correcting, go ahead and correct it. So here's my sketch. I have quantity on the bottom, the amount, okay, and I have price on my y-axis, okay? So it's decreasing, okay? So if I only want one, if I only have one available, the price is going to be really high, okay? But if I have a lot available, the price is going to be really low, okay? So I would kind of start with those two dots if you're struggling how to draw your line, and then you would just sketch it. And that's it. See you tomorrow.